Hello students, welcome to today's video. In this video, we are going to discuss about the Gauss law. Okay. So before going to the Gauss law, let's first quickly revise the formula for electric flux. We have already done the electric flux. We have already studied about the electric flux in our previous video. So in this video, we are just going to quickly revise the formula for electric flux, and that formula is going to be used in the Gauss law. Okay. So first, let's consider a surface. We have considered the surface to be S. In this surface area, we have considered a small area element ds, right? In this surface, we have considered a small area element ds. Now, what will be the direction of the area vector? The direction of the area vector will be perpendicular to this surface, okay? So, this is the direction of the area vector ds. Now, let's suppose the electric field, the direction of the electric field is along this direction. Okay, the electric field is along this direction. So what is the angle between the electric field and the area vector? What is the angle between the electric field direction and the area vector? It is considered to be theta. Okay, for this case, what would be the electric flux associated with this small area element? That will be nothing but E ds cos of theta. We have already got this formula, we have studied about this, so we are just writing the formula just to quickly revise it. So d phi, which is the small electric flux linked with this surface, that will become d phi is equal to E ds cos theta. Now this is nothing but E dot ds, so what we have derived is d phi is equal to E dot ds. Now if we are going to consider this whole area, so what will be the electric flux for this whole area? The whole area is considered to be S. For this area S, what will be the value of the electric flux? So how can we get that? We will just have to integrate d phi. Okay, we will have to integrate d phi for this whole surface. Then we are going to get the electric flux linked with this whole surface. So we have just integrated the value of d phi, that is integration of E dot ds. See, if here E is a constant quantity, if the electric field is constant, if it does not change, then we can consider this case. That is, if E is constant, then we can keep E outside the integration. Therefore, what we get is phi is equal to E integration of ds. This is nothing but the total electric flux linked with this whole surface. And what is integration of ds? If we integrate these small elements ds, what we will get? We will just get the whole surface area. That's why I have written here integration of ds to be s. Okay, this is we have considered the vector quantities, so this is nothing but E dot ds. So what is this? This is the total electric flux linked with this whole surface element s. Let us now come to the statement of Gauss law. Now what does the Gauss law states? It states that the total electric flux through any closed surface in free space is equal to 1 by epsilon naught times the total charge enclosed by the surface. So what does it signify? See, we are going to calculate the electric flux, the total electric flux in the Gauss law. Okay, so what we have to consider? We have to consider just a closed surface. A closed surface means a three-dimensional surface, a 3D surface which is closed from all sides. Okay, so for the closed surface, we are going to calculate the total electric flux in Gauss law. And what is its value? It is 1 by epsilon naught times the total charge enclosed by the surface. So if we consider a surface S, and we have written here in free space. So in free space means either air or vacuum. So if we place a closed surface, so we consider the surface to be S. If we place this closed surface in either in air or vacuum, and if this surface contains Q charge, if there is a charge Q on this surface, we have considered the charge to be Q. If there is Q charge on the surface, then what will be the value of the electric flux? Okay, so the total electric flux through that surface will be equal to 1 by epsilon naught times the charge enclosed by the surface. So what will be the value of the electric field or electric flux? The electric flux will be equal to 1 by epsilon naught times the charge enclosed by the surface. So what we get is phi E is equal to Q by epsilon naught. Okay, So we have calculated the electric flux for a closed surface which consists of a charge q, or we have written here small q, so the charge is considered to be small q. Therefore the electric flux is q by epsilon naught. This is nothing but the Gauss law. In the next step we are going to prove the Gauss law. But before going to the proof of Gauss law, let's first discuss how the Gauss law would be if the system or the surface is placed in some medium. So what we have got up till here is the Gauss law, that is phi E electric flux is equal to 1 by epsilon naught times the total charge enclosed by the surface. Now we also know, we have already come to know that the electric flux is nothing but the closed surface integral of E dot ds. Okay, so in that case we can also equate this with q by epsilon naught. Since phi E is also equal to q by epsilon naught, therefore we may write this equation as phi E is equal to closed surface integral of E dot ds, which is equal to q by epsilon naught. Now what does this symbolize? What does this mean? This is the integration over a closed surface. We have considered the surface to be ds. This is a small element. We have considered the surface to be ds, which is the small element, or we may also consider, if we integrate, we are integrating for the whole surface s, right? So for this we are performing the integration over the whole surface. That means we are performing the integration for a closed surface. So if we put a ring on this integration symbol, so what does this mean is that it is a closed surface integral. That means the integration has been performed for the whole surface, which is a closed surface. Now if the system, or if the surface is, if the 3D surface is placed in some medium, what will be its value? See, first of all, if we place the surface in air or vacuum, which is the free space, then its value would be phi E is equal to q by epsilon naught, right? If we place it in some medium, then we get phi E to be q by epsilon naught, epsilon naught. Here we have put epsilon. Why? Because this is the permittivity of the medium, whereas in this formula epsilon naught is the permittivity of the absolute permittivity of free space, and we have put, in this case we have put the system or the sheet of charge in some medium. Okay, we have put the 3D surface in some medium. For that medium the permittivity is epsilon, so in that case the electric flux should be q by epsilon, where epsilon is equal to epsilon r into epsilon naught. Here epsilon r signifies the relative permittivity, right? And what is epsilon naught? Epsilon naught is nothing but the absolute permittivity of free space. Next we are going to prove the Gauss law. Now how do you prove the Gauss law? In order to prove the Gauss law, let's first consider a sphere which is a three-dimensional surface. Okay, we have considered a sphere of radius r, and we also consider that there is a point charge at the center of the sphere, which is q. Okay, so what we have considered here is, we have considered a sphere which is a three-dimensional surface, and at the center of the sphere there is a charge q, right? So if we consider the electric field to be along this direction, then what is the electric field at every point of this sphere? We have to first calculate the electric field at every point on the surface of this sphere. For that we have considered a small area element ds. Okay, we have considered a small area element ds. Now what is the direction of the area vector for this small area element? That will be perpendicular to this surface. So we have the area vector for this element along this direction. Okay, now this is the electric field vector, this is the area vector for the element. What is the angle between E and ds? That is nothing but 0 degree. So what is the electric field intensity at every point on the surface? The electric field intensity at every point on the surface of the sphere will be equal to, you already know the formula, E equal to kq divided by r square. Okay, if we consider the radius of the sphere to be r, then every point of the sphere, every point on the surface of the sphere would be at a distance of r from the charge q, which is at the center. Okay, so this distance will be r. Similarly, from here up till here, the distance will be r. So every point is at a distance r from the center of the sphere, and at the center of the sphere there is a charge q. So what is the electric field intensity at every point on the surface of the sphere? That will be equal to E equal to kq divided by r square, where q is the charge and r is the radius of the sphere. Now we consider a small element ds on the surface of the sphere. We have considered a small element ds on the surface of the sphere. What is the direction of E along this direction? What is the direction of ds? It is perpendicular to this surface, that is, it is along this direction. So what is the angle between E and ds? That is equal to 0 degree. The angle between E and ds is equal to 0 degree. What will be the electric flux linked with this small area ds? The electric flux linked with the small area element ds will be equal to d phi. Okay, since the area element is small, therefore the electric flux will also be small. So we have considered d phi e for the small area element ds, which is the electric flux. This electric flux associated with small area ds will be equal to E dot ds. Okay, what is E dot ds? It is nothing but E ds cos theta. Now what is the value of theta? Theta in this case is 0 degree. So what this becomes is E ds cos 0. The value of cos 0 is 1. So what would be the value of d phi? That will be equal to E dot ds. So what we get here is that the electric flux associated with this small area element ds will be equal to E ds. So what will be the total electric flux linked with the whole surface S? Okay, so the total electric flux linked with the whole surface S. This was a small surface element ds, and the surface of the sphere, the whole surface of the sphere is taken to be S. For that surface, what will be the total electric flux? It will be integration of d phi. What we have to do is, in order to find out the total electric flux associated with the area S, we have to just integrate this value, that is d phi. So we have just integrated d phi for the whole surface. So I have taken closed surface integral. We have done closed surface integration for d phi e, and d phi is nothing but E ds. So if the electric field is constant, we have taken the electric field to be constant in this case. So if the electric field is constant, then E can be put outside the integration. Okay, so what remains is integration of ds. This is closed surface integral of ds. Now we put the value, we substitute the value for the electric field, that is kq divided by r square. This is the electric field intensity. Next, if we integrate the surface ds for the whole surface, if we integrate the value of ds, then what are we going to get? We are just going to get the whole surface area of the sphere. Now what is the surface area of a sphere? It is nothing but 4 pi r square. So if we integrate ds over the whole closed surface, then we are going to get 4 pi r square, which is the area or the surface area for a sphere whose radius is r. Here I have just put the value of k. So the value of k, which is the constant, is 1 by 4 pi epsilon naught. Q divided by r square will remain. So q divided by r square into, what is this? This is 4 pi r square. The term 4 pi r square will get cancelled out. Here we have 4 pi r square in the numerator, and there is also a term 4 pi r square in the denominator. So these two terms will get cancelled out. What remains is phi e is equal to q by epsilon naught, which is nothing but the Gauss law. So this is the proof for Gauss law. Finally, what we have got? We have got a total electric flux linked with a closed surface S, and in this case we have considered the surface of a sphere. So for this we have got the total electric flux linked with the surface of the sphere to be q by epsilon naught. This proves the Gauss law. Now from this formula, what we have got for the electric flux, from that formula we can just observe 2 points, that phi does not depend on the dimensions of the sphere. So see, in this formula the value of phi e, electric flux, depends only upon the charge q and the absolute permittivity of free space epsilon naught. Okay, so this formula or the value of electric flux does not depend on the dimensions of the sphere. So this formula can be used for any surface. see, in this case, if r gets changed, the change of the value of r does not affect this value, does not affect the value of electric flux. Why? Because this formula does not depends on r. Okay, so what we see is that the value of electric flux does not depend on the dimensions of the object or the dimensions of the surface. It just depends upon the total charge enclosed by the surface and the value of epsilon naught. Second point what I have written is phi does not depend on the size of the closed surface. So as you have seen that the value of phi does not depend on the surface on the dimensions of the object, so it also does not depend on the surface area of it does not depend upon the surface area or the dimensions of the surface area of the object or the three-dimensional surface that we have taken. Okay, so this is what we have seen is the Gauss law. Thank you.